video number 61. What, got one cool guy, Euclid, there joining us today. He would be, let's see, how many years old? He'd be over 2,300 years old right now. This video is about unions, intersections, and complements. Mr. Lewis, say goodbye to surveys and experiments.
Bye.
We're on to something new. Back to math. All right, so this video is about learning about union, intersection, and complements, very much related to the words and or.
Yes. So and would include the intersection part in the middle.
Right.
Whereas or includes everything. That's a union.
So usually we talk about unions and intersections, we refer to sets. So we have a set of geometry students, like a geometry class. So Maria, Ralph, Courtney, Anna, and Freddie are in geometry. And then we have 5 students taking Spanish as well. Anna, Freddie, Jose, Tim, and Sam. So we have these 2 groups of people. And if we want to know the students in geometry and Spanish, that means both, which is intersection. So
right.
How many are both?
That would just be Anna and Freddie.
Man, are we prepared today? We got this all set up. Okay.
Somebody must have made this edit.
Anna and Freddie are both. So the Venn diagram helps us to identify what's in both. Okay. So which students are in geometry or Spanish? The word or causes a little bit more trouble. Or means in geometry, in Spanish, or both.
Right.
Okay. They're in at least one of them.
Yes.
Okay. So how many students are in at least one of them?
Well, that would be almost all of them.
All of them. Yeah. So when we didn't list the names twice. So when we list
you don't
how many are in both sets, we don't put Anna and Freddie twice.
Yeah, you don't count twice.
Okay. So everyone in this diagram, not in all diagrams, but in this diagram, everyone's in at least one of the classes.
Yes.
All right. So and means both, or means in at least one. Okay.
Okay. So let's try another one.
Okay. This one I think you actually have to write, Mr. Lewis.
Oh.
So here are 2 sets of numbers. Okay, so a set is just a list of numbers. Could you underline set A up there? So that's set notation. Not everyone necessarily has seen that. Those little curly brackets on the left and right side means it's a set. It's just a list of numbers.
Those are called braces.
Thank you.
Yes.
I never had braces.
English.
And the rule for a set is you're either in or you're out. So so we don't list repeats. You're either a member of the set or you're not.
Right.
Okay, so set A has 4 numbers, 1, 2, 4, and 6. Set B has 4 numbers. And as long as it's only 2 sets, a Venn diagram is useful for illustrating it.
Yeah, well, a Venn diagram can be useful for 3 sets as well, but once you get 4 or more, it can get kind of cumbersome.
Yeah, you can Google that. It's a mess. Anyway, so, all right, so same thing. Which numbers are in set A and set B? So the numbers that are in both. So there's one number that's in both.
Right there. 6.
Okay. So we just look for what's in both. And the second one, which numbers are in set A or set B? That's all the numbers that are in at least one of them.
Right. So that would be all.
Yeah, and this is the union. So Mr. Lewis get busy writing those.
So actually we could put it in set notation again.
Using his braces.
1. Yes. 2, which I'm not good at making. 3, 4, 5, 6, 7.
Okay, and now you need some commas. Very good. We separate the elements with commas.
So many punctuations.
Now, this is called union, kind of like marriage. So it's where you put these 2 together. So when we find all the numbers are in at least one of them, we're forming the union. And just think marriage. Putting them together, they become one big set.
Right.
Okay.
Later we'll talk about divorce.
All right. Is that intersection?
Yes.
All right.
No, I don't think so, actually.
So the other thing I want to talk about are complements.
All right. Complement.
So the complement of set A is everything that is not in set A.
Right.
So it's everything outside of set A. So it says which numbers are not in set A. So Lewis, what are they?
Well, in this set, it would be almost everything that's in set B except for the 6. So it'd be these 3 guys right here. Okay, because 6 is actually still part of set. So it'd be 3,
so everything that
5,
is not in A.
and 7.
Good. Which numbers are not in set B? That would be the complement of B.
Yep. So again, that would be the 3 numbers that are in set A. So it'd be 1, 2, and 4.
Cool. All right. We're going to need all this for probability. Let's see what's next. All right. So here we're just going to practice. Mr. Lewis, we had trouble making the intersection sign, so go ahead and fill those in. That one's supposed to be intersection.
Yeah, it's supposed to be upside down U, some
Okay,
reason the font changed. So whenever you see the upside down U, that's your and.
Okay, so maybe you can write and above here. So usually with sets, we have to talk union and intersection. We use those symbols. We got to understand the upside down U is symbol for intersection.
Mm-hmm.
What's in both? So which numbers are in set A, or the first set and the second set?
Well, I see a 2 here, 2 here, I see a 4 here, and a 4 here. So I'm going to guess 2 and 4.
Okay, and then put the set braces because this is like addition and subtraction. When you add two numbers, you get a third number. When you subtract two numbers, you get a third number. Same thing here. This is kind of like for sets. This is like arithmetic for sets. When you take the intersection of two sets, you get a third set.
Mm-hmm.
Okay. All right, so on this one, we're going to find intersection also. So I see an 8 in both.
Yep. 8, and 16.
Good.
8, 16.
All right. The next one is union. Everything that's in at least one. So C is a union. So we're kind of putting these sets together, but we don't list repeats. What I kind of do is I just write the first set. So I write 2, 3, 5, 7.
2, 3, 5, and 7.
And then I copy everything down we don't have already.
0, 1, and that would be it.
Yeah, so
between that 0 and 1.
Right. So that's what you get when you put those together and eliminate the repeats. So that's union.
Mm-hmm.
Okay, next one.
Okay, so here we have 1, 4, 9, 16.
Yeah, we just need to add what things from the second set we don't have already.
Which would only be the 8.
Okay, so you got to remember, intersection, the upside down U goes with and union goes with the word or. Everything that's in the first set, second set, or both.
Mm-hmm.
Okay.
Okay.
Ooh, geometry. This goes back. A lot of people miss geometry. Shade the intersection of the circle and the square. So we got to shade the area that belongs to both. The part of the area that's in the circle and in the square. So that's an intersection. And maybe put the intersection sign up there. That was the intersection. And we got to fix it on the bottom too. I know, a lot of fixes. There we go. Now, shade the union of the circle and square. That'd be all the area that's in at least one of them. So it's either in the square, in the circle, or in both. So it's kind of like putting those two areas together. All right. So that represents the union.
Yes.
Okay. That's the way to look at it from geometry.
Mm-hmm.
All right, Lewis, what else we got?
It's their turn.
Oh, yeah, cool. Now, we got to fix some signs for them. So
Okay.
Lewis will fix those while I describe it. So in the first one, we have two teams, soccer team, basketball team. So for A, find all the players that are on soccer and the basketball team. And for B, find the list of players who are on soccer team or the basketball team. Then, on the right side, number 2, get used to set notation. Your answer should be a set for the ones on part 2. So we have 4 problems involving sets. We should have 4 answers with sets.
Sounds good.
All right. Then do a lot of that, what that guy is doing.
Yep.
All right.
You can relax after your stats video that you probably watched Monday night.
Okay. Good luck.